All right, so
With the road, I'm gonna stop talking.
a little bit of additional material on regression, some follow-ups on some things we did earlier. Yeah, that's what they call this chapter, regression wisdom.
Facts.
So, remember that a residuals plot and I will totally cop to, I usually call it a residual plot, but it's supposed to be called a residuals plot, should show no particular pattern. No regression analysis is complete without one. If you haven't done a regression, a residuals plot, you could be wrong. Okay?
Or wrong.
Now, be really careful about this. Just because there's no pattern in the residuals doesn't mean that you have a good model. Okay? You can't go backwards like that. If there's a pattern in the residuals, then you know you've got a problem, right? But just because there's no pattern doesn't mean that the model was a good one. Okay? So this particular one, I think I took this one from the book just because I couldn't find one that was as good anywhere else. Notice that you have this group up here that has large residuals compared to the rest, and this group down here that has large negative residuals compared to the rest. There may be something going on. You may actually have 3 different groups that you should be separating out and giving a different equation for each type. Does that make sense? So it could be that these need to have a different equation than this data. And these need to have a different equation than either of the others.
So if there are patterns within the patterns on the residual plot, then it might be better if they're on a separate scatter plot.
Yeah, it might be better to figure out, all right, is there something about these that causes them to have a high residual? And can we then go, okay, like on the one from today where you were doing the car tread, the tread and the tire, it may be that once it gets past a certain place, that it wears down really fast because the rubber is cheaper further in, right? And so for cars over 50,000 miles, we have to do this for a different equation for the tread wear. Or maybe, pardon?
I said, or there's no way to wear down. It's flat.
It's flat.
Yeah.
Once you get to 0, that's a different problem, but yes. Or it could be, that the initial layer has, I don't know, some extra protective coating on it, and it doesn't wear as fast at first. Okay, so for cars under 10,000 miles, we would use a different regression equation. Okay? All right. So, something to be cautious about. Extrapolation.
How do you spell that?
Extrapolation.
That actually didn't help as much. Polation?
Pollution.
See, I was going to palation.
Polation.
Polation.
Extrapolation. That's where the explanatory variable is beyond those in the data at either end. Most of the time it's on the high end, but it could be on the low end as well.
I don't know what that means.
So, okay, so for example, again, going back to today's test, you had on the tires, right? They only had data, I think it was up through like 50,000 miles. If you were using that regression equation to estimate how much tread would be left after 75,000 miles, that would be a bad idea because it's outside of your data set.
They use that on the answers of the homework problems. Like whenever it asks you to interpret the y-intercept, they're like, because of extrapolation.
Yeah, and some of the ones I tried to avoid those because we hadn't talked about extrapolation. Was that in the review?
I think I remember seeing it on one of the answers. Like it explained it like in another way, but it said that.
Yeah, and you see this happen all the time. People do. I mean, I've seen ones where someone takes, a very small section of time, which like 10 years, which doesn't sound like a small section, but depending on what you're doing, that's very small. And then they extrapolate 20 years beyond that, and you're like, okay, you're making a lot of assumptions about things remaining the same. Okay, now I have my own personal bias about things don't change all that fast. I mean, the important things. There are some things that change really fast, but there's a lot of things where it's like, doesn't really change all that fast. I'm sort of an incrementalist at heart. You made a face when I said incrementalist.
It's just big words.
Yes. I have another big word for you.
Oh, what is it?
University.
Oh.
Actually, I had a psychology professor who, during the middle of one of his lectures, a student raised her hand and asked him not. And first of all, in college, you don't, unless you go to a really small school, you don't have this. You don't have the back and forth and stuff. And in fact, you don't interrupt them while they're talking. You just let them talk unless they ask, are there any questions? You speak when spoken to for the most part. And apparently in the middle, and she's like raising her hand and all that. And eventually he's like, yes, ma'am, can I help you? She goes, could you not use so many big words? And he said, I have another big word for you, university. And I've remembered that for 30 odd years now.
That's brilliant.
All right. So, so sometimes we have points where if we were to omit them, they would change our model by quite a bit, either because they're outliers or because they're high leverage points. We call these as a total influential points.
Bless you.
God bless you.
TAL or TIAL?
It's a TIA.
Teal.
TIAL. Sorry,
Sure.
I left off the I.
That's valid. I don't know how I just like am slacking so much when it comes to spelling. Like I don't know
She
what
skipped
we're
that
on.
course.
So anytime I think of that, it makes me think of influencers, and then it makes me think of Star Wars, where Obi-Wan Kenobi in the very first movie said, the Force has great powers over the weak-minded. It's like, yep.
It always makes you think, would I have done the Force? Probably.
All right. So either of those can have a great effect. So one of my favorites is there's one where there's a set of data like this, and then there's, oh, whoops, not like that. Let me try that again. There's a little click thing on this, and I don't know what it's supposed to do, but when you're trying to draw, it just makes it go all over the place.
Wait, do it
Auto
again.
drawer.
It's the autumn drawing.
No, I
So
missed it.
you missed this. Hang on a second. Wait, I can't make it do it. It's one of those accidental things.
Can't do it.
The click thing?
Oh yeah, there it is. So like I'm not even near it anymore.
So you have to touch it to.
So you can like touch it and then pick it up.
And
You
then
can touch it again. What?
so if this point's not there, then
Wait, what?
This- this
Yeah.
point
Okay.
is not part of your scatter plot
Oh, that's
So
got
hold-
of
It's
the
an
little
outline.
circle.
of this little circle.
Yeah,
then-
probably belongs to those.
Your R value is going to be quite low. It's not very linear. But once you add this point, you get a much better R value because you just draw, through the middle of this, and you're like, oh, hey, look, none of those are.
Is that a high leverage point?
That's a high leverage point. Indeed, it is.
Job.
Thank you.
Okay. So here's one in bold. Must be important. No matter how strong the association, no matter how large the R square value, no matter how straight the line, there is no way to conclude from an regression line alone that one variable causes the other. I think that's a
That
pretty,
was on the test.
yeah,
No.
Yeah,
Yeah.
it's not-
we've talked about it.
Yeah.
Yeah,
Yeah.
but we're just emphasizing it again.
Okay.
Okay? Going on with observational data as opposed to data from a designed experience, there's no way to be sure that a lurking variable,
Ooh.
Oh my god.
that's what I'm going to dress up as for Halloween.
Which variable will you choose?
The
Hmm.
working one.
Just
One of the ones that lurks.
Do you like age or something?
Eight.
There's cool
Okay.
variables in that.
So just as an example, a simple example, generally speaking, geese fly south for the winter. It also gets colder in the winter.
Geese. Like it does not get cold because the geese leave,
Precisely.
but the geese leave because
Oh,
it's
it does
cold.
because their body
Um,
mass, like
Frequently, they
heat
leave
of
before the
body.
temperatures change very much.
Because they know.
They are
They,
chronologically wired.
they know.
The heat from their bodies like warms up the earth.
Facts.
Global geesing.
All right. So, never interpret the regression slope coefficient as predicting how y is likely to change if its x value in the data were changed. So for example, in the data set that we have used multiple times of a bookstore where we're comparing sales to the number of people, remember salespeople, right? We've done that one a bunch. The slope was $0.913,000 per salesperson. It would be wrong and kind of stupid to say adding one additional salesperson is expected to add $913 additional in sales. Notice how that subtly implies causality?
Oh, that's so nitpicky.
It is subtle, isn't it?
Yeah, good grief.
So a better way to say it would be on a day where there is an additional salesperson,
Oh.
we will tend to have about, and again, squidgy words, about $913 more in sales. Okay? And then this last idea is, I was like, there's nothing to leave out of this, but so scatter plots of statistics summarized by groups tend to show less scatter than the baseline data on individuals. And so they can give a false impression of how well a line summarizes the data.
Got it.
So for example,
I don't know.
if we look at the mean high temperature over the last 20 years for each day in August in Houston, this is just, it's like Keystone Cops in here.
Good call.
We will see far less variability than if we did the individual days. Okay? This is why I always dislike it when places go, oh, well, the average high temperature in August in Houston is like 92 degrees.
Incorrect.
Actually, correct.
Correct.
However,
Like that one day where
they're including those days where you had the massive thunderstorm and it didn't get above 75.
Arg.
Those outliers tend to move that. Okay? And so when you're doing the average, especially if you're doing an average of an average, because what they do is they average together each day and then they average together the month. That shows a whole lot less variability than if you're looking at the individual ones. I honestly want people to start giving the median high temperature. I know. How big a nerd am I? Start a revolution. Because the average high temperature doesn't tell you what you really want to know. What you really want to know is, on a typical day, how many shirts are you going to sweat through?
Quite a few.
Okay?
Quite a few.
Yeah, possibly 4. All right. Any questions about any of that? All right. I sent you 2 different files today. One of them has the answers to Chapter 8.
Yeah.
Yeah.
Oh, we can find out who wins in 3 minutes. I bet you won.
Dancing Queen or Dancing King?
Dancing King.
I think this is
Yeah, I think that's Rose. I haven't seen
I
it.
didn't
She wearing
see
the
it.
wig.